Imagine uncovering a hidden gem in the world of art. Scientists have recently identified a rare blue pigment in one of Jackson Pollock's most celebrated works. But here's the twist. This pigment is now off limits for use. Jackson Pollock, an iconic figure in American art, is renowned for his unique approach to abstract expressionism, particularly his distinctive drip and splash technique and the immersive all-over style of painting. His piece, Number 1A, 1948, is a prime example of this innovative artistry. Recent research has finally shed light on the chemical composition of the striking blue hue that Pollock so expertly incorporated into this masterpiece. Using a sophisticated method known as laser spectroscopy, which allows scientists to analyze materials at the atomic level, researchers have determined that the vibrant blue in Pollock's painting is manganese blue. This particular pigment, which has a turquoise-like appearance, is no longer in production. The findings were published in a study in the journal PNAS, marking the first confirmed instance of Pollock's use of this pigment in his artwork. The researchers described Number 1A, 1948, as a quintessential representation of Pollock's action painting technique, where dynamic layers of color, including drips of black and pools of white, come together to create a visually captivating experience. While previous studies have identified the red and yellow pigments that are part of Pollock's signature palette, the vibrant blue had remained a mystery until now. To clarify, pigments are specific chemical compounds. Manganese blue, for instance, is chemically known as barium manganate VI sulfate. According to Abid Haddad, a co-author of the study and an assistant conservation scientist at the Museum of Modern Art, MoMA, this pigment was first discovered in 1907 and patented in 1935. It was widely used by artists until it was phased out in the 1990s due to concerns regarding its environmental and health impacts. It's important to distinguish between pigments and hues. A hue refers to the color we perceive, which can be created by mixing different pigments. For example, combining a blue pigment with a yellow one results in a green hue, but it does not create a new green pigment. The research team also delved into the chemistry behind the unique color of manganese blue. The molecules of this pigment consist of a manganese ion, which is a charged atom surrounded by 4 oxide ions. Edward Solomon, another co-author and chemist from Stanford University, explained that the blue color arises from the way these molecules absorb light in the purple and green wavelengths, allowing the blue light to be reflected back to our eyes. But why does it matter to pinpoint the exact chemical makeup of a pigment? In the realm of art conservation, this knowledge is invaluable. As Haddad pointed out, understanding the specific pigments used in artworks can inform effective display strategies, especially since many pigments are sensitive to environmental conditions like intense light, ultraviolet radiation, and humidity changes. Additionally, knowing the pigment composition can guide conservators in selecting appropriate treatment methods, as certain chemicals may react negatively with specific pigments. So, a gentle reminder to all artists out there. Consider the future of your work and the challenges faced by conservationists. Keeping a record of the pigments you use in your creations can make a significant difference in preserving your art for generations to come. What do you think about the implications of this discovery? Do you believe artists should be more mindful of the materials they choose? Share your thoughts in the comments.